Welcome to everybody. I'm Bharath Dhananjaya. Today I'm going to cover the basic fundamentals and design architecture of CouchBase. So these are the agendas I'm going to cover in the today's session: introduction to CouchBase server and how you can install CouchBase server, and what is the prominence of admin web console used within the CouchBase, and high level architecture of CouchBase and buckets, design document, and how the CouchBase SDKs are available and what are those SDKs, and specific to a .NET, what are the client libraries, and what is cluster management. So the brief on NoSQL: we all know that NoSQL databases are more scalable and provide superior performance, and it's very much used wherever you think that there is a latency with regard to performance and you cannot scale your databases horizontally, and you wanted to make sure that the auto sharding and replication, all these things are taken care very much. So in this case, NoSQLs are playing a very key role, and we all know that there are many NoSQL databases are available in the industry. They are CouchDB, MongoDB, Cassandra, and HBase, and Node.js, and also many more are available. And before going into the NoSQL databases, so I'll just give a brief on CAP theorem. So this is one of the theorem everyone needs to be aware of. Like CAP, we know that consistency, availability, and partitioning. So all the databases which we use it, so will be belongs to one of this category. So like consistency is means for it always makes sure that the data available in one node is also present in another node, and availability here is a important part where it makes sure that always the request and responses are available, and whenever whichever node I go, that the data will be available for me. Partitioning is that where it makes sure that the data are partitioned into multiple nodes. So rather vertically, it's here horizontally the data are moved across, and make sure that the performance and the data will not be a bottleneck when the data moving from one node to another node. Okay, so what is CouchBase server? CouchBase server is a distributed document-based database that is part of the NoSQL database movement, and CouchBase server is a persistent database that leverages an integrated RAM. So the main important things to remember in CouchBase server is its integrated RAM caching layer. The CouchBase server is provides a caching mechanism by using its inbuilt RAM technology. So where it makes sure that once the data is read from the physical drive, so the next time the data will be read through a RAM, and it is persisting its key and value, so that it doesn't need to go to a physical drive. So it always fetches the data from the RAM, and supports both key value and document oriented use cases. All components are available under Apache 2.0 public licenses. Okay, so you can get the CouchBase servers in two models. One is community model and other one is enterprise model, and you can get all sort of features in both the cases, whereas the community model is not supported by the CouchBase team, but if we are good enough to handle all sort of use cases, so you can both are the free versions. Community model is a free version basically, so and you can get all sort of features what is there in the enterprise model. Only advantage in enterprise model that you will get the full-fledged support from the CouchBase team. Okay, so these are very important features we need to focus on. They are easy scalability, consistent high performance, and always on high availability. So that is 24/365, and flexible data model. So these are the things which needs to be addressed in the today's session. Yeah, and before we are going to the CouchBase, we just wanted to get a basic difference between a CouchBase and versus to one of the relational database. So CouchBase server is very good enough in sort of key document pace and well suited for applications which handle rapidly growing list of elements. And in the case of RDBMS, we must knowing that data stored in tables with a fixed relations. We cannot say that data can be scattered anywhere, and it has to be can be chosen you cannot say that I can choose a dynamic schemas within the RDBMS. And the CouchBase server, you have asynchronous operations and optimistic concurrency enable application design for high throughput, whereas in case of RDBMS, it's strict enforcement of a data integrity and normalization. So these are the things which we need to be adhered to when we are choosing any RDBMS system. Okay, so CouchBase servers are rapidly scalable to millions of users, wherever RDBMS is scalable to thousands of users. And if we wanted to give more performance, then we need to build hardware, vertically, to make sure that sort of clusters we need to build it, where the things will be scaled vertically. Okay, so data can be structured, semi-structured, and unstructured, whereas in case of RDBMS, data must be normalized. And CouchBase server, the data can be flexible, stored as a JSON document or binary data, and no need to predefine data types. And whereas in RDBMS, data types must be predefined for columns. Okay, so the relational approach to model data. So whereas I'm just giving on the right hand side, take the sample of any order management system, where you can see order ID, customer, line items, and payment details, so which will be associated to the corresponding tables, and how it looks like. And compared to a document database, so if you look at the previous slide, where you can see that how the document is being converted into various tables, but in this screen, wherever you are converting the same use case into a document, so where the document is nothing but here is a JSON document, which is a key value pair, which makes sure that your user ID, customer, line items, and payment details are mapped in sort of key values pair. And this is the data model, how it looks like. So basically flexible database model, and no need to worry about the databases. No fixed schema, allows data model changes for a rapid application development. Since it's a JSON is a very lightweight sort of data format, and where you can say that key values can be built and it can be extendable. It's always open closed, so rather you modify, you can say that I can extend my keys and values based on my new use cases. And the main features are it supports JSON and indexing and querying, and integral MapReduce, and cross data replications. Okay, JSON support natively stored as a JSON, and it's not only JSON, it also supports the other format of data. And but JSON is the one very much used, because the nature of its format, it's a lightweight, and also it's very easy to read it on the UI interface, like if you're using a jQuery or something, which is very native to the JSON format. And indexing and querying looks aside your JSON build views and querying, so similar to indexing and querying which we build it in RDBMS. So you can build indexes and make sure that the performance is built. And incremental MapReduce. So the incremental MapReduce is one of the key feature of the Couch database, so which I'll explain in the upcoming slides. Cross data center applications, where you make sure that in case of any redundancy or disaster recovery, the data will be moved across the data centers, so that if in case of any sort of one data center go down, the data will be available in another database. Okay, so these are the additional features which we can cover within the CouchBase. All nodes are equal. When I'm talking about a node, is nothing but a physical server over here. Single node type, easy to scale your cluster, and no single point of failure. So if you can build a cluster which is a group of servers, so where you can make sure that the documents will be placed in that particular physical nodes, and you can treat it as one cluster, and you can also build multiple clusters based on the use cases. Okay, so every node manages same active data and same replica data. Data is distributed across the cluster, and hence the load is also uniformly distributed using auto string. And you can see the other features as well. Mobile devices, I don't think that Couch database is used only for building any web applications. It's also used in building the mobile devices. So CouchBase Lite is the one which is already available for the mobile databases. We know that there is a NoSQL Lite, and in the case of SQL World, so similarly the CouchBase also has come up with CouchBase Lite, so which is used for purely mobile devices. So this is a high level architecture of CouchBase. So you can see that it has internally memcache, and also the CouchBase EP engine. So it internally works with a REST API, where how it interacts with the databases, and gives the response back whenever the query gets executed. And main components of CouchBase we need to remember is CouchBase server or node, which I'm telling is a physical server. In every case of a relational DB, you will have a separate node is nothing but a physical server. Cluster is nothing but it's a collection of one or more nodes. And caching layer, we already know that the RAM is an integrated part of your CouchBase management, which caches the data. And cluster manager, every node within a CouchBase cluster includes the cluster manager component. The cluster manager is responsible for following within a cluster management, node administration, and node caching, node monitoring. And we also have a data manager and cluster mapper. Okay, so CouchBase clients uses the cluster map provided by the cluster manager to discover which nodes holds the required data. So it's a very common questions like, let's assume that my data is placed in node A and node B. How I will make sure that when I'm querying that I have to go and fetch my data in the node A itself, because I don't specifically mention that from which node I need to query the data. So this is the cluster mapper is the one which will make sure that the appropriate nodes will be picked while the request comes. Add nodes to clusters. So this is a simple architecture where you can say that how you can build a cluster. Within that you can add multiple servers, multiple nodes, so where you will have active and replica, where every data writes to active node will be also replicated in another node. So in case of any failure, it is making sure that the data will be fetched from the replica server. Failover node, similar to that, if one node goes down, so it will be fetching the data from another node, because the data are already replicated in another node. Buckets, so buckets are very important here. So in the relational world we will call it as a database. Here is buckets, where it contains list of documents. Okay, buckets, those terminologies are different. So Couch uses in buckets in terms of database name. So there are two types of buckets. We have CouchBase, which reflects the two types. One is the data storage that we use on a CouchBase server. Can partition your data into separate buckets with a CouchBase server, and also you can separate with buckets. So we'll explain that how the bucket structure will look like. So we normally have two types of buckets when you're going to create a CouchBase buckets. One is a CouchBase bucket, another one is a memcached. CouchBase bucket is stored on the physical drive, memcache is on the RAM. So memcache RAM, which will be used only for the content loading and all those things, because you cannot expect that the RAM can hold so much memory, and also for a longer duration. vBucket is a defined as a owner of a subset of a key space of a CouchBase cluster. These vBuckets are used to allow information to be distributed effectively across the cluster. The vBucket system is used both for distributing data and for supporting replicas. Okay, so vBucket mapping. So we all need to know that we talked about cluster mapper. So like similarly, vBuckets which will play a key role in picking which data is available in which node. So we will have multiple vBuckets which has not been exposed to outside, or no one will be know. It is the internal mechanism of the CouchBase design that each node will be having a list of vBuckets assigned. So vBuckets will be first will be invoked by your client manager, and it will be addressing to which node it has to go and pick the data. So coming back to CouchBase SDKs, we have various SDKs available in Java, .NET, PHP, Ruby, and so that's one of the very good advantage of the CouchBase, because CouchBase SDKs are available in many important programming languages, so that someone who start writing a web service or something, who can directly use Java, .NET, or PHP, Ruby, and many more are available. So which you can use it, and you can see on the extreme right hand side, it's very simple for you to connect to a database and invoke the CouchBase client. There's a connection between client and CouchBase. So when you are going to call the assemblies, we basically have application, client, SDK, and cluster map. So internally your cluster map will be looking for addressing which cluster I need to go, and within the cluster it will make a decision which node the data has to be fetched. These are the CouchBase SDK client libraries available. So as I said, .NET, Java, PHP, C, and Ruby, and all those things are there. So specific to .NET Framework, .NET Framework 3.5 and later, it is supported. And if you wanted to write a program from .NET connecting to CouchBase, you need to have 3 basic DLLs. You can download it and keep it forever. There's a CouchBase.dll and name.caching.dll and Newtonsoft JSON.NET for serialization part. So this is what I was talking about, the CouchBase SDK client libraries, and so many more to come. I will be taking more sessions on the CouchBase, how we can practically design it, and the internal architecture in the next session. So thank you all.